Hello and welcome to our course on vulnerability management. This course is designed to provide comprehensive overview of vulnerability management which is tailored specifically for security analysts. Over the course of this module, we will cover fundamental concepts and some key components of the vulnerability management program. We will also provide hands-on experience with market-leading vulnerability scanning and management tools including Nessus, OpenVAS, Qualys, VMDR. By the end of this course, one will have the knowledge and the skills necessary to effectively identify, assess, and remediate vulnerabilities within the organization or IT infrastructure. So let's begin with the fundamentals. This document is providing an in-depth exploration of the vulnerability management, which is very critical aspect of cybersecurity. It's a foundational resource designed for security analysts and anyone who wants to understand and mitigate security risk. Now, this is what a hierarchy of vulnerability management looks like. It has multiple components involved, such as reporting and monitoring, remediation and mitigation, prioritization and risk management, vulnerability scanning, and asset inventory. We are going to see each and every one in the practical also, as well as in the theory module also. Let's start and see something very fundamental. Now, what is a vulnerability? If we are going here to become a vulnerability engineer or a vulnerability manager, lead vulnerability analyst, whatever are the job roles available in the market, all are revolving around the vulnerabilities. So what is a vulnerability? Now, a vulnerability can be defined as a weakness, or you can consider as a flaw where in the system, application, or the network. A threat actor could exploit this flaw to gain unauthorized access, or it can disrupt services, or they can cause any other form of harm. So vulnerabilities aren't just limited to software. They can also exist in the hardware or even in the process policies that govern how the systems are going to be utilized. Essentially, a vulnerability is any gap that allows an attacker to compromise the confidentiality, integrity, and availability of an asset. So the CIA triad is going to be in danger because of the vulnerability is a gap. Now, vulnerability manifests in various forms, okay? And we need to understand the common types, which would be very crucial for effective remediation, if you do. So, what are the common types where the vulnerability are existing? Software bug is one of them. What is a software bug? So, any error in the code or an application. So, whenever we write a piece of code, for example, I have something called as my HR software. So we have an application. Now any code that is written, let's say we have written in the C++ language. So this C++ language would be having some sort of vulnerabilities present, any weakness that is written in the code. So any errors in the application or the operating system's code, such as like it can have SQL injection, cross-site scripting, etc., etc. Then we have something called as misconfiguration. So this would occur when the systems are not configured according to the best practices possible inside the internet. Now, the attacker can easily exploit because they represent readily available pathways, maybe default passwords or open ports or incorrect file permissions. Different types of things are already open up. For example, if you are using default password for any of the service, and if attacker is able to reach out to that particular IP address or the domain name, then they can log into that service with the default password without any challenges. Why? Because we are using not a secure password. This is a misconfiguration that is found out. There can be some design flaws. Okay, design flaws means the architecture itself is having some flaw. For example, we have an application that is running a database. Any user from the internet can access this particular database without authentication. This should be not a good approach. So design flaws are something that inherit weaknesses in a system architecture. So if you check the complete architecture, this is the user, this is the database, this is an application, and via the internet user is able to go. So if we have not applied proper authentication in the web application, then it can lead to the existence of the vulnerability. We may be using outdated softwares. Outdated means older versions. Now people are still using Windows 7, Windows 10. Microsoft has already created end of life for Windows 7 and soon it would be releasing up for the Windows 10. Point here is, if anyone is using the software that is no longer supported by the vendor that is manufactured. For example, Windows is maintained and manufactured by Microsoft. Then the vulnerability would be unpatched, and that can present a significant risk. So attackers are usually targeting the known vulnerabilities in the older software because they are easily exploited. Then there is a weak cryptography. So if the encryption we are using is very weak or outdated, or we have not implemented the protocols correctly, it can again be a source of the vulnerability. For example, cryptography or encryption is utilized for communication. If device A is communicating to device B, there should be encryption created so that the data is not readable in the normal text. But if the encryption way is being done via outdated modules, the attacker can still decrypt it and read the actual data. So there is no privacy is maintained. That is the main concern here in the weak cryptography. And as usual, we have human error in the place. So these are the mistakes that are made by the users or administrators. For example, someone is sharing a phishing email to us, or we are now accidentally exposing a lot of data to, let's say, ChatGPT or any other tools without knowing the impact. So these also can create the possibility of vulnerabilities, because the data that we have shared can be actually be used against us. So these are the sources of vulnerabilities, the cause. Now we have some impact of vulnerabilities on organization. Now the impact of these vulnerabilities on the organization can be very severe, far-reaching, affecting operations and reputations. For example, data breaches. An exploited vulnerability can lead to data breaches, because when sensitive information like customer data or intellectual property is stolen, this can result in significant financial losses or maybe legal liabilities, and also reputational damage. Financial losses, legal liabilities. Now we are required to comply with certain types of regulations, and if one fails, this can make them legal trouble. So if we have a proper vulnerability assessment and management plan, we can be assured regarding certain types of losses that can occur. So we have something called as insurance here if we properly follow the vulnerability management. We can also face service disruptions. So vulnerabilities can be exploited to disrupt critical services, leading to a loss of productivity. Now imagine we are using an outdated software for our server. We have a server which is using, let's say, Windows OS, and that is typically Windows 7, which is fully outdated. Now if attacker has exploited this particular vulnerability, the server itself gone down. Now the server is itself gone down. If the server is down, we are not able to provide the services. Let's say an application was running on this particular Windows platform, maybe HR software, maybe our website. We don't know. Any of the application that was running is now not accessible to the genuine users. So if vulnerabilities is exploited, it can disrupt the critical services. So if, let's say, our website is down, we are losing the productivity, revenue, as well as customer trust. So service disruption is again one of the key areas that needs to be checked. Again, financial losses, reputational damage, and legal consequences that we faced here also, the same thing would be covered up. Financial losses is the cost that is associated with addressing vulnerabilities, and recovering from the security incidents can be substantial, because the cost can include, now you need to engage incident response plans, remediation, legal fees, fines, consultancy, lots of things. It's said, right, prevention is always better than cure. This would make us more severe if we don't follow the plan properly. We may face reputational damage. Now imagine you are using MasterCard and Visa for all your online transaction, credit card, debit card. Now you find that Amazon is storing the particular card, and maybe Amazon has faced a data breach. Now we are going to be bit reluctant to use it up, the services of Amazon, because we have already found that no, our data may not be completely secured of using this particular platform. It can be anyone. So for an example, let's consider this one. Security incidents can damage the organization's reputation, leading to loss of customer trust and business opportunities. So now the new user would not sign up because it has already been known in the market that we have been observed in a data breach, and we need to face legal and the regulatory consequences. Many industries are subject to regulations. For example, HIPAA compliance we need to follow if you are operating in healthcare industry. One has to follow GDPR if someone is operating with European customers' data. So many industries are subject to regulation to protect sensitive data and maintain adequate security controls that are getting failure to comply with this regulation. So if you do the failure, you need to pay fines, penalty, or any other legal actions towards your particular organizations. So this is how the particular vulnerability management program would help us out. In the next sections, we are going to explore the different options of vulnerability management program that would allow us to be more mature regarding the particular terms and technologies we utilize. After this, we are going to completely done the theory sections.